have the notes in front of you, you see that in those notes in front of you, you have the definitions for sine, cosine, and tangent of an angle. And this is exactly what it looks like on your reference sheet. Okay, so you don't have to memorize sine, cosine, and tangent, although you'll probably find that you do so kind of almost by accident. Some of you may have heard of the expression SOHCAHTOA. SOHCAHTOA. Why is that significant to us? Why does that help? Look at these definitions. The sine, S, equals opposite over hypotenuse. There's the OH. You see the same idea with the cosine. Its definition is adjacent over hypotenuse. And tangent, definition is opposite over adjacent. Okay? So, in the first problem of our notes, you see that we are simply being asked what are the sine, cosine, and tangent ratios for angle P. Okay, so find where angle P is. We are setting up the sine of P, the cosine of P, and the tangent of P. This problem is just using the strict definitions of sine, cosine, and tangent. We're not doing anything with it yet. Okay, so the definition of sine is side opposite over hypotenuse. So looking at angle P, what is the side opposite angle P? The 15. So 15 over, what is the length of the hypotenuse? 17. There it is. There's the sine of P. Cosine of P is defined as the side adjacent to angle P. And the struggle that frequently arises at this point is that some students will say, but Mrs. Clouse, there's two sides that are adjacent to angle P, and you're right. However, I like to think of the hypotenuse as like a VIP, and he does not want to be confused with Mr. Adjacent, so don't you dare confuse him with just, adjacent, because the hypotenuse is always the hypotenuse. The adjacent depends on what angle you're talking about. Okay, so what is the angle, what is the side adjacent to angle P that isn't the hypotenuse? The 8. And it is over, that 17 is still my hypotenuse. And then finally, the tangent of P is what? What over what? The 15 over 8. So far, so good. Strict definitions. Now comes the fun part of actually using this in our calculator. We have from this screen what we need. On the screen, you see the your turn, which I really don't want to use as much as a your turn as a little bit more practice with this. Okay, so we're all together here. In part A, first thing you need to identify is what trig ratio you're using. So you're looking at the angle, you're looking at the sides, and you're asking yourself what trig ratio uses those sides. So the sine, please don't say sine, like a dagger in my soul. Okay, sine. All right, so we're using the sine of 54 because the W is opposite the 54, the 17 is the hypotenuse, and according to your notes, the trig ratio that uses opposite and hypotenuse is the sine. So sine of 54 equals opposite over hypotenuse, so W over 17. Notice where the variable is this time. It's on the top. That's a happy place for a variable to be. Yes, ma'am? What you need to realize, adjacent to what? It's opposite the 54. Do you see that now? Okay. So, you're not going to switch anything across a diagonal. What you're going to do is take 17 times the sine of 54 in order to get W by itself. And again, those of you that see the word sine on your screen, you get to type this in exactly the way that it looks. Those of you that don't see the word on your screen, you're typing in 17 times the angle sine. And let me get an answer so you have a basis of comparison. Where's my calculator go? And don't forget to hit equals. W is 13.8. Awesome. Music to my ears. And again, if you're not getting that, then perhaps we need to change a mode in your calculator, or perhaps you need to familiarize yourself with what keystrokes you're using. Yeah. Yeah. Part B. What trig ratio would I use for part B? I would use the tangent, yes, because the 1 is opposite, the W is adjacent. So our equation would be tangent of 28 equals 1 over W. Am I doing any switching around here?
Yes.
Yes, because my variable is on the bottom, let's switch across the diagonal just to facilitate our calculation. Our new equation becomes W equals 1 divided by the tangent of 28, and now you know exactly what to do in your calculator to get that answer. And I have 1.9. Good? How about part C? What trig ratio would I use for part C? The cosine. So, ladies, stay focused, please. Cosine of 33 is what over what? W over 4.5. Am I having to switch anything across a diagonal here? No, W is nice and pretty on the top, so 4.5 times the cosine of 33 will give me the value of W. Okay, in the interest of moving on, I am going to stop the question. And our overwhelming, there we go. Our overwhelming majority selected 44. We had a couple of 43.9s who didn't read closely the instructions that said round to the nearest foot, not the nearest tenth of a foot. Be really, really careful about that rounding stuff. If you're kind of what I don't see it, here it is. Oh, that's not what I wanted. I got too much stuff up here. Okay, there it is. There's the steps for how you would have found our answer to be 44. Up to it. So I have a cliff forming an angle of 84 degrees with a lake. So you kind of got to visualize what's happening here. I have this cliff, and it's overhanging over my lake. And it's making an angle of 84 degrees. So there's my 84-degree angle. And it says if I stand at the edge of the cliff, so here I am, standing at the edge of the cliff. Don't jump in the stars. And I'm dropping a rock. And I would hope that you'd see the right triangle that's formed there. Now, the height of where I'm dropping the rock is 48. And what I'm trying to find out is how far from the cliff the rock will strike the water. So here is my x. And we have to use trigonometry in order to find that value. Before we use the trigonometry, though, we have to define what trig ratio we're going to use here. And here's the thought process of how you do that. You look at where the angle is, you look at where the sides are, and you're asking yourself, what combination of opposite, adjacent, and hypotenuse am I looking at here? And based on that combination, you're selecting what trig ratio you're using. Okay, so step by step. What is the 48 to the 84-degree angle? Opposite, adjacent, or hypotenuse? It's opposite. What is the x? Adjacent. So opposite and adjacent, look back at those definitions if you have to. What trig ratio will we use if we're dealing with opposite and adjacent? The tangent. So we write our equation as tangent 84. You might want to make a note to yourself that what you're taking the trig ratio of, this must always be an angle. Very frequently, one of the mistakes that I see students make is try to take the tangent of a side. You can't do that. The definition, notice, says tangent of angle A, sine of angle A, cosine of angle. You can only take the trig ratio of an angle. All right, so tangent of 84, well, the definition of tangent is opposite over adjacent. So what's on the other side of my equal sign? The 48 over x. Okay, but I'm going to tell you right now, x being in the denominator is kind of an unpleasant place for x to be. I don't like x being in the denominator. It makes it hard for me to do calculations to figure out what x is. So, something that we learned last chapter is, if I put that tangent of 84 over 1, do you see that I now have a proportion? And last chapter, one of the things that we learned we were allowed to do with a proportion is switch things across the diagonal. So let's do that. We're going to switch these two things across the diagonal. And now I'll have x, I don't need to write down the over 1, equals 48 divided by tangent of 84. And before you go typing that into your calculator, if this is the first time you've ever done trigonometry with your calculator, you might not know the order of the keystrokes you need to use. Okay? So, do me a favor and hit the tangent button in your calculator first and foremost, because I'm going to break calculators down into two kinds. There's either the calculator where the word tangent is on your screen, or the word tangent is not on your screen. Okay? So when you hit the button tangent, if you see the word tangent on your screen, clear your calculator, and you're going to type this in exactly the way that it looks. If the word tangent does not show up on your screen, your calculator requires that you type in the angle first and then the trig function. Okay? So I'm going to get an answer on the screen so that you have a basis of comparison, and then we'll troubleshoot. Today. In Friday's notes, we learned how to use trigonometry in order to find segment lengths. Today's lesson is all about using trigonometry to find angle measures. Look at your calculator. If you don't already have your scientific calculator out on your desk, get it out. If you look at your calculator, you should notice that above the sine, cosine, and tangent buttons, there's the shift function for that button, or the second function for that button, and that's the sine -1, cosine -1, tangent -1. Everyone sees that in their calculator. Okay? Those are the inverse trig functions. And the inverse trig functions are what we use to find angle measures. Okay? You have that kind of spelled out for you in your notes. I would urge you to highlight it, circle it, whatever you need to do so that you remember that the only time you're hitting shift for these problems is if you're finding an angle measure. You're only using an inverse function to find an angle measure, which is what we're doing in problem 3. The setup of the equation, however, is exactly the same idea as what we were doing on Friday. You look at the angle, you look at the sides, you decide what trig ratio you're going to be using. So in problem 3, I'm asked for angle T. So I look at angle T, I look at the sides that I know, that's 7 and 13, and I decide what trig ratio I'm going to use based on that. So looking at angle T, what is 7? Is it opposite, adjacent, or hypotenuse? It's opposite. How about the 13? What is that? It's the hypotenuse. So I need the ratio that uses opposite and hypotenuse, and that's the sine. So our equation, as I was saying, oh no, it didn't. Look at that. It just disappeared. All right. So much for that. Our equation is sine of t equals 7 divided by 13. Now, since we're using the inverse function to find the angle, what we're basically doing is taking the inverse sine of 7 over 13. And again, those of you whose calculators show the word sine when you hit that button, you're typing it in exactly as you see it on the screen. Do be mindful of the parentheses. Parentheses are important. If you have a calculator like mine, where the word sine does not show up on your screen, then in your calculator you need to do 7 divided by 13 equals, and then shift sine. And let me put the answer on the screen so we all know whether we're getting it right or not. Shift, second. Hold on. Let me get the answer. Okay, hopefully you've started to move on to the next problem. In the next problem, I would hope that you'd realize that since the 8 is adjacent to the t and 10 is the hypotenuse, this time we'd be using the cosine. Yes, sir. Okay, hypotenuse you should know. The side opposite the right angle. Side opposite the right angle. Okay. The adjacent side is the side that's next to it. And the point of confusion that I often have to deal with is, well, darn it, this is because the hypotenuse is also adjacent to the angle, but the hypotenuse is like a VIP. Okay, so the hypotenuse is just the hypotenuse. It is not the adjacent side. Okay, and then opposite is the side that's facing.